The most important concept in mathematics is number concept. To acquire number concept, we need to look at the components of number concept. What are the key skills involved in learning number concept? And the second part is to look for those materials which are more efficient, effective, and at the same time can be generalized further. I generally call that our instructional materials must have 3 E's. They must be exact, they must be efficient, and they must be elegant. Efficient means that I can do something very quickly, easily, with less involvement. And effective means that it gives me the result I'm looking for easily and effectively, in the sense that I get it. And elegance means that it's generalizable. It can be extrapolated. It can be abstracted. That means what I learn in one context, I'm able to apply that in other contexts. From that point of view, I have found that number concept involves few key skills. The first one is, do I really have numberness? Numberness means, can I identify a collection of objects by just looking at it? Up to 5 objects, when they are given in a collection, we have an innate ability. Children come to school, children come to kindergarten with this innate ability to be able to identify, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6. Even 6 is possible. This ability is called subitizing. It is innate. It is not just in children, human beings. It is also in many animals. Dogs, pigs, many birds have this ability to recognize a collection of objects up to 5 or 6 by just visually observing it. Our goal in preschool and kindergarten, and even in first grade, is to extend this subitizing ability to visual clustering. When we can identify a collection of objects in any form, then we have actually acquired the visual clustering. It should be done up to number 10. One of the materials, as a starting point, is the visual cluster cards. Visual cluster cards help us in the second skill necessary for mathematics learning, and that is called, or number concept learning, and that is called decomposition recomposition. Decomposition recomposition means I see a big collection and I'm able to break that big collection into smaller collections. For example, here is the 5 card. Now, as soon as I see this 5 card with few exposures, I'll be able to say that's 5. But at the same time, I also see there is a 3, there is a 2. There is a 4 and there is a 1. There is a 3 and there is a 2. There is a 2 and there is a 3. This ability to break this 5 cluster into 2 cluster and 3 cluster and visualize that in the mind's eye and put it together, that when I see a 2 cluster and 3 cluster and I say that's 5 cluster, that is called decomposition recomposition. Decomposition recomposition is just like phonemic awareness. What role phonemic awareness plays in reading, decomposition recomposition plays in number conceptualization. Just like in reading, we need to have sight words. Sight words are acquired by just visual observation. They are not by any strategies. They are not by any recognition of individual letters. A sight word is that we are able to see that and say that is such and such word. Similarly, in number concept, in mathematics, we need to have sight facts. Sight fact, a new term, I have used it, I have created it to give an ability for dyscalculic children, acquired dyscalculic children, and children who are having difficulty in number conceptualization, children who have difficulty mastering arithmetic facts. For them, the mastery of sight facts, and therefore for all children, mastery of sight facts is a prerequisite skill. What is a sight fact? When we look at the card 5, we say there are 5 things, and I say 2 plus 3 is 5. I did not count. I did not use any strategy. And therefore, I learned that 2 plus 3 equals 5 by sight, by observation. So, arithmetic facts, addition facts, subtraction facts, which are learned by just observation, they're called sight facts. So, visual cluster cards are very good for learning the sight facts also. For example, when I take the 4 card in my hand and a 5 card in my hand, right away I can see that 5 is 1 more than 4. And not only that, I can say that when I'm seeing the card, I also have the picture of that in my mind. There is a 4 card, and if I put that in the middle, it'll become the 5 card. 4 plus 1 equals 5, or 1 plus 4 equals 5. A little later, when I have mastered this 5 card, and I take the 7 card, and I say, oh, look at that. I see a 5 on that 7. I see a 2, so 5 and 2 must be 7. Now, initially, when I'm taking the 7 card, I might learn it by counting it. Few exposures, I will know the image of that 7. But when I'm counting, I have to be very careful. I count 1, 2, 3, 4, 5, 6, and then 7. Why am I counting it this way? Because when I count 1, 2, 3, I'm decomposing that 3. Another 3, and another 1. But I remember the 6 card. The 6 card looks like this. So I say, oh, I have made 6 first, and then I added 1. When we ask children to count it in a haphazard manner, for example, if I say 1, 2, 3, 4, 5, 6, 7, that does not create that sight fact ability. That does not create that decomposition, recomposition. And then when I say, look at, isn't that a 5? Isn't that a 2? And don't the 5 and 2 make 7? Right away, I have learned the side fact that 5 plus 2 equals 7, or 2 plus 5 equals 7. When I say, look at, I know the 3, look at that, that is a 3, and I see that 3 on that card. So therefore, this card is made up of 3 and then 4, because I know 4 looks like that. So now I have the image of 7 in my mind, and I say 6 and 1 is 7. 1 and 6 is 7. 5 and that 2 is 7. 2 and that 5 is 7. 3 and 4 is 7. 4 and 3 is 7. Those were the sight facts of 7. When I have the pictures of these in my mind, I'm able to transfer it to visual representation. In other words, I can write it. But the writing must take place after I have orally said these facts. I have visualized these facts. So from that perspective, the movement in teaching is from concrete to pictorial to visualization to abstract. This visualization is a bridge between pictorial and abstract. The pictorial is a representation and a bridge between concrete and abstract. These are the 4 steps: concrete, pictorial, visualization, and abstract. Now, if we continue a little further, look at this card. Now, I show it to the child, and the child doesn't know how many are there, so I help him to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 8 and 1 is 9. Then the child begins to say himself or herself, I see a 5 here, I see a 3 there, I see a 6 there, I see a 4 there, I see a 7 there. In other words, the child can point out all the previous clusters on that 9 card. Now, 9 cards and few other cards have a multiple representation. For example, on this card, there are 9, but here I want to emphasize the 6ness and 3ness. 3, 3, 3, 3, 3, 3. So that picture is made in the mind's eye. Here, I want to heighten that there is a 3 and there is a 6. There is a 5 and there is a 4. There is an 8 and there is 1. And by showing it in multiple forms, the child begins to generalize it. Then that 1 which is here. Also, the 1 doesn't have to be there. It can be there, it can be there, it can be there, it can be there. In other words, as a matter of fact, sometimes you might even put it on the side, 8 and then 1 there. So by this visual clustering, we have one-to-one correspondence, we have counting, we have decomposition, recomposition, sight facts. When we have this, we can derive any facts. We can master any arithmetic facts. So we know, if I know the sight facts of 10, sight facts of all the numbers up to 10, there are 45 sight facts. There is only one sight fact for 2, 2 sight facts for 3. Why there are 2 sight facts of 3? Because when I take 3 card, there is only 2 ways I can say 2 plus 1 or 1 plus 2. So the number of sight facts for a number is 1 less. So 2 has 1, 3 has 2, 4 has 3, 5 has 4, 6 has 5, 7 has 6 sight facts, 8 has 7 sight facts, 9 has 8 sight facts, 10 has 9 sight facts, and if you add them together, there are 45 sight facts. Visual cluster cards is one of the best ways of learning the sight facts, learning decomposition, recomposition, and then when we have this one, we can extend it. Now I want to find out 8 plus 6. Oh, I wish I had 2 to make that 8 into 10. Now, why am I asking for 2? Because I know the sight facts of 10. Oh, so I got 2 from 6. So there are 4 left in that 6. How do I know that? Because I know the sight facts of 6. So the sight facts must be mastered before any other arithmetic fact is mastered. So 8 plus 2 is 10, and 10 and 4 is 14. Prerequisite skills for mastering arithmetic facts are, I must know the numbers up to 10. I must have the 45 sight facts. I must have decomposition, recomposition, and I must know the teens numbers. Now, to learn the teens numbers, that means 10 and 4 is 14, 10 and 7 is 17, the best method is Cuisenaire rods. Cuisenaire rods are so effective that we can learn teens facts in no time. For example, if you look at here, these are the Cuisenaire rods. These were designed by a Belgian mathematician, and he was very successful in helping children to learn number facts. As a matter of fact, the colors can give you an idea that there is some Montessori aspect is present. Montessori was the first actually a pediatrician who became an educator. She was working with children who were having a great deal of difficulty in learning. They came from the Rome ghettos, and they had very little education. So she designed lots of materials which are even today very popular. So Cuisenaire rods is a mix of 2 aspects. One, our brain receives information better when there is color, shape, size, or pattern. Color, shape, size, and pattern. Look at visual cluster cards. It is the color and the pattern. In Cuisenaire rods, it is color, shape, size, and we see pattern. That when we look at the staircase, we can see, oh, it looks like that 2 is 1 more than 1. 3 is 1 more than 2. 4 is 1 more than 3. Notice the child doesn't have to count. When we ask children in kindergarten, pre-kindergarten, first grade, what is 6 plus 1? They don't say 6 plus 1 is 7 right away. They will count the 6, and then they will count the 1, and then they will say 7. Cuisenaire rods reduce all that counting work. As a matter of fact, there is no need to count. That doesn't mean that we should know how to count. We should know how to count, but we should not be using counting for deriving arithmetic facts. So here are the 10 Cuisenaire rods. Now, they're organized very beautifully. If you look at the red, purple, and brown, warm colors, 2, 4, 8. And we look at light green, dark green, and blue, cool colors, 3, 6, and 9. They are arranged so that it's very easy to memorize the number with the color, color with the number. So before we use the Cuisenaire rods for any arithmetic facts work, we must really memorize them by connecting the number with the color, color with the number, and it doesn't take too much time. As a matter of fact, I play a game. I tell the children, I want you to look at the staircase, and I want you to tell me which color is missing. So I take one of them, and then I close them. And then I say, is anything missing? And the child looks at it and says, oh yeah, each one of them is one more, but there is more gap here. I think there's a rod missing there. And then if we have exposed them for a few times, they will say, I don't see the dark green one. That must be the one. Then I say, so what number is that? Well, 5 is yellow, and that's the next one, which is one more, so that must be 6. So by playing some games like that, we can actually learn them quite quickly. Once we have learned them, I say, I'm going to play a game. I will pick up a rod, and you have to say the number associated with the rod. And a little later, I'll ask you to pick up the rod for the number I'm going to say. So I might say 5, and they pick up the yellow one. Then I say 9, they pick up the blue one. Then I say 15, and most children, kindergarten, pre-kindergarten, say, there's no 15. I say, why didn't you make a 15 then? Well, that's a 10, and with very little help, they are able to say, here, that's a 15. And then I say, what two numbers make 15? Oh, 10 and 5, 5 and 10. 15 is made up of 10 and 5, 5 and 10. And notice I'm putting it in the order, place value. So how many 10s are in your 15? Oh, 110. How many 1s are in your 15? Oh, 5 1s. And then I say, take it and put it on top of that calendar and see where is 15. And where will you put this one? And where will you? And they automatically go, most of them. Some may need a little bit of help. They put the orange rod on the 1 of 15 and the yellow on 5. So I say that, what does that 1 represent? Oh, that 1 represents a 10. So then I say, what digits make 15? 1 and 5. What numbers make 15? 10 and 5. And then record it on your paper. And then put this on top of that part. So these are very good for teaching teens numbers. But they're also very good for sight facts. So I just did the sight facts of 5 using the visual cluster card. Then I take the children to an arrangement of Cuisenaire rods. So I say, here is 5. So if I put 1 here, what number will fit there? And with a little bit of effort, they find out, oh, 4 will go there. So 1 plus 4 equals 5. 4 plus 1 equals 5. 5 equals 1 plus 4. 5 equals 4 plus 1. Notice, the most important thing Cuisenaire rods develop is the idea of equality. That 1 plus 4 equals 5, 4 plus 1 equals 5, and 5 is equal to 1 plus 4. In our schooling, most children think of addition as a one-way implication. 4 plus 1, I get the answer. But when you ask them, 5 is made up of what two numbers? And they have difficulty. So equality is a two-way implication, left to right and right to left. And Cuisenaire rods emphasize that part. Then I say, what if I put 2 rod here? What number will go? Oh, it's going to be 1 less than that 4. And if they don't see that, you help them to see that. 3. So now read it in 4 ways. 2 plus 3 is 5. 3 plus 2 is 5. 5 is 2 plus 3. 5 is 3 plus 2. So now I have 1 plus 4 equals 5. That's one side fact. 4 plus 1 is another side fact. 2 plus 3, another side fact. 3 plus 2, another side fact. And now I can complete it so that they can see a pattern. 3 plus 2, 4 plus 1. And a little later, I will say, well, am I adding any number at the end of yellow? No. So I can say 0 plus 5 is 5. 5 plus 0 is 5. And the color, shape, and size and the pattern helps them to memorize these side facts. 2 most important materials for learning number concept: the side facts, decomposition, recomposition, and then extending it to learn all the arithmetic facts are the visual cluster cards and Cuisenaire rods.